Dear viewers, here we discuss IPE problems. Question number 14, mathematical induction, long answer questions. Here, question number 14. What is question number 14? Use mathematical induction to prove the statement sigma k is equal to 1 to n 2k minus 1 whole square is equal to n of 2n minus 1 2n plus 1 by 3 for all n belongs to capital N. So n belongs to natural numbers. Okay, all of you. We want to prove this statement by using mathematical induction. So what is the given statement? You see, given statement, let S of k, S of k or S of n, S of n is equal to sigma k is equal to 1 to n, 2k minus 1 whole square is equal to n of 2n minus 1 into 2n plus 1 by 3. How to write this statement? You see, all of you, this statement here k is equal to 1, 2 minus 1, 1 square. 1 square, k is equal to 2, 2 into 2, 4, 4 minus 1, 3 square, plus 3 square, plus 5 square, and so on, plus 2n minus 1 whole square is equal to, this is n into 2n minus 1 into 2n plus 1 by 3. So this is the statement S of n. This is the statement S of n is equal to. Okay, all of you. By using mathematical induction means first step is n is equal to 1. For n is equal to 1. LHS. LHS, this is S of n or S of 1 is equal to 2n minus 1. 2 into 1 minus 1. 2 of 1 minus 1 whole square. This is 2 minus 1. 1 square is equal to 1. RHS. RHS n of 2n minus 1, 2n plus 1 by 3. By substituting n is equal to 1, 1 into 2 minus 1 into 2 plus 1 by 3 is equal to 3 by 3 is equal to 1. Then what we conclude that? What we conclude that for n is equal to 1, for n is equal to 1, S of n is true. For n is equal to 1, S of n is true. So this is the first step of the given problem. We want to go second step. Here, what is the second step? N is equal to k be true. For n is equal to k be true. We want to prove n is equal to 1 is true. N is equal to k be true implies n is equal to k plus 1 is true. So that is the process of mathematical induction. So n is equal to k be true. What is S of k is equal to? This is, we can written as 1 square plus 3 square plus 5 square plus so on plus 2k minus 1 whole square is equal to k of 2k minus 1 2k plus 1 by 3 equation 1. Okay, all of you. From this equation, we want to prove n is equal to k plus 1 is true. So, this is the first term, this is the second term, this is the third term, and so this is the tk term, kth term. So, we want to, that is tk plus 1th term, add both sides above equation of equation 1 of equation 1. Okay, all of you. Here, this can be written as 1 square plus 2 square plus 1 square plus 3 square plus 5 square odd numbers plus 2 of k minus 1 or 2k minus 1. 2k minus 1 whole square. What is the k plus 1th term? 2 of k plus 1 minus 1 whole square is equal to k of 2k minus 1 into 2k plus 1 by 3 plus you add this one. This is 2k plus 2 minus 1. So 2k plus 1 whole square. Okay, all of you. Here, the simplification of this is 2k plus 1 whole square. Adding both sides, k plus 1 term. Then after simplification, what we will get? Let us we see. Here, so this is implies up to here what? S of k plus this is 2k plus 1 whole square. 2k plus 1 whole square is equal to, here LCM is 3, k of 2k minus 1 into 2k plus 1 plus 3 of 2k plus 1 whole square. You observe here 2k plus 1, 2k plus 1 common. Then 2k plus 1 by 3 as common, k of 2k minus 1 plus 3 of 2k plus 1. Okay, all of it. So, by simplification, 2k plus 1 by 3 of this is 2k square minus k plus 6k plus 6 plus 3, sorry. This one plus 3. Okay, all of you. Then this is equal to 2k plus 1 by 3 of 2k square plus 5k plus 3. So by factorizing this one, 2 into 3. 2 into 3 is equal to 6. This can be written as 2k, 3k. This is uh, the process. Okay, all of you. Then this can be written as 2k plus 1 by 3 of 2k square plus 2k plus 3k plus 3. So 2k plus 1 by 3. Factors of this one, 2k as common, 2k as common, here 3 as common, 2k plus 3 of k plus 1 factors. So here 2k plus 1 by 3, this is 2k as common, k plus 1. Here 3 as common, k plus 1. So k plus 1 into 2k plus 3 are the factors for this one. Then what we can conclude that here this is process. So S of k plus k plus 2k plus 1 whole square is equal to, this can be written as k plus 1 first into 2 of k plus 1 minus 1. 2k plus 1 is written as 2k plus 2 minus 1. 2 minus 1 is 2k plus 1 into 2 of k plus 1 plus 1 by 3. Okay, all of you. K plus 1 you write first. 2k plus 1 you write like this. 2 of k plus 1 minus 1. 2k plus 2 minus 1 is 2k plus 1. Here this can be written as 2 of k plus 1 plus 1. 2k plus 2 plus 1. 2k plus 3 is there. Okay, all of you. What is this? This is the S of k plus 1. S of k plus 1 statement. So what we conclude that for n is equal to 1, true. N is equal to k, be true, implies n is equal to k plus 1, true. By using principle of mathematical induction, statement S of n is true for all n belongs to capital E. Okay, all of you. This is the conclusion of the problem. So, this is the conclusion of the problem. Thank you for watching my video.